Very easy, very understandable. Let's now move on to the next part of today's session 2, the functions, which is going to be really fun. Okay, let's now look at functions. Functions. All right, so let's assume a scenario. For example, you have a quadratic equation, okay, and you want to create a you want to take the user input of x and solve 3 steps after that x is obtained and return the final value. Okay, basically you want to take x as an input, okay, this is a comment. Okay, you want to take x as an input, run step 1 plus step 2 plus step 3, 3 steps one after the other using x, and finally return the output of the run as y. This is something that I want to do. Ideally, the way to do that is, for example, x equals to, let's say, 3. Okay, step 1 is to apply some quadratic equation, let's say x to the power 2. Step 2 is step 1. I want to add some, let's say 5 to that. And step 3 is step 2 multiplied by x. Okay, and I want to return the value of step 3. Basically, this is like wasting a lot of lines of code for nothing, and this is not even clear. Basically, what we are doing here is x squared plus let's say, 5x, let's say, okay, 5x plus 5, step 2 plus 5, okay, so that it looks like a quadratic equation. Okay, so x squared plus 5x plus 5. Okay, this is something that you want to do. Now, will you keep on writing this quadratic equation everywhere you go down the code? For example, if you are 1000 lines down the code, now you don't even remember what were the coefficients of the quadratic equation. So the code reusability is in question here, and we still have to, every time, even if you remember, you would have to type the entire long statement again. What if there was a way to create a function of that that takes in as an input, it takes in x as an input, does some computation, returns the output as the y, and you can use it wherever you, and it has a name that you provide it, and you can use it wherever you want. So that's where functions come in. So let's create a function. The way to create a function is def keyword and then function name, then inputs, and then return some outputs. Okay, output equals to input plus 1, let's say, inputs plus 1, and then a return statement. Okay, so you can see function name, and you can use it like this. Function name, you provide an input. So this input 10, it goes and it is assigned to this inputs variable, which goes inside the function. That is added, 1 is added to that input statement, and output is printed out. Okay, so basically if I run it, you can see 10 goes into the function, 1 is added, 1 is assigned to output, 10 plus 1 is assigned to the output, and the final output is returned, which is this one. So this is the entire theory of a function. What if I wanted to do the same thing for this quadratic equation? Def quadratic. Now this blue name is your creation. You can provide whatever name you want. Okay, quadratic calculator. Okay, you ask for an x input, and that y value is basically nothing but this quadratic equation, and you can return the value of y. So basically whatever happens in here is private. No one can see it except you. Because when you are using a function, for example, now you are using this function, all you have to do is provide the x value, x equals to 2, and it runs. Okay. So I will give you everyone, I want you guys, whoever has the programming console open on their end, I want to give you guys a problem statement. Okay. Example problem. Create a function squarer that takes x as an input and returns x, the square of x. I want you guys to take a shot at it and paste your functions inside the chat. I want you guys to try this one and paste whatever function you have created in the chat so that I can understand, I can see that you have understood at least the syntax of how to create a function. I've given the example here, and let's take 1 to 2 minutes for whoever wants to solve it. And I'm expecting answers in the chat. Perfect. Looks like everyone's able to understand how to create it. So the way to create it is def keyword will always be there. It is Python's identification that it's a function. I see correct answers in the chat. Good stuff. So squarer, x as an input, x squared equals to x to the power 2, return x squared. And to use it, so this is called a function definition, guys. Okay, this is called a function definition. This is like a template that the function is following, and this is called a function execution. Okay, this is called a function execution or function call. So I can use it now. Squarer, when I provided 3, the output should be 9. Now remember, it's again like this function is popping a value out based on the computations. Whatever you are returning, it is popped out, it is thrown out. It's like a fruit. A function is a tree, it is throwing a fruit out. So you can create a polybag as a variable, x squared, and now x squared will have stored the value. X squared will have stored the value, right? So this is about a function. Now, the problem here is if I use the squarer function and I don't provide any input, it will give me an error because a function is expecting an input. There are 2 ways to solve this problem. Let's look at the first bad way, okay? Which is called default arguments. What you can do is while defining a function, squarer, let's call it squarer new. We can provide a default value to the function x to be 0 as default by default, so that whenever I run this function again, If I forget somehow, if I forget to provide X, the program still runs. This red kind of bad looking error, it does not show up. So now I want you guys to tell me, if I run the same thing again without any input, what will be the output? If I run it just like this, I'm not providing any X. If I run the squarer new without any input, exactly, it will not give an error this time. So you see just how much of a difference providing a default statement, default value makes to the function. Okay, so now this comes in handy. Let's look at multi input functions. Okay, we can ask for multiple inputs to the function, right? For example, def Gaussian. So I think all of us know that the Gaussian function is e to the power something like e to the power minus x squared plus y squared, something like that. Okay, so in that case, we want two inputs, x equals to, let's say, if I provide x without default argument and y with a default argument of 0, I can calculate z equals to, I know that the value of e is 2.71 something. Okay, to the power minus x squared minus y squared. Okay, if I am incorrect about the Gaussian formula, pardon me, but just assume this is some calculation that has two inputs and some calculation that you don't want to tell the world. That's why you're creating a function. Return z. Now tell me, if I run Gaussian without an input, will it run or will it give me an error? Simple question. If I run it without any input, will it run or will it give me an error? It will give us an error because yes, we have y with the default argument, default value. One input is still not defined. Okay, so you need to understand that at bare minimum, one input has to be defined. So if I provide 5 as an input, what is 5 now? What is 5? 5 is x. So you can see the final output is returned. Okay. However, you can also override the default arguments. You can be like x equals to 5, y equals to comma, y equals to 3. This is why they are called positional arguments, because x goes to the variable defined in its position, y goes to the variable defined in its position. So 5 goes to this variable, 3 goes to this variable. Okay. So if I run it, now it runs. Now, again, one more example. Okay. One more example. Def random func. Okay. X equals to 2, y equals to 3, z equals to 4, l equals to hey, m equals to pro. Okay. And inside the function, we do nothing, but we just print. We don't, there is no mandate to return something. We can just print ha ha ha. Okay. Just a bit of laugh. Now tell me something. If I run this now, I'll reframe my question. What is the minimum number of arguments or the inputs that we need to provide here when we are executing the function? How many minimum number of arguments does the random func need? Brilliant, Krunal. We don't need to provide anything because absolutely every single argument has a default value with it. So if I run it, you can see the ha 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 happens even without any input statement. But if I remove two of them like this, x comma y, now tell me how many minimum number of inputs we require for our random func. Okay, exactly. And when I run it this time, you can see this is exactly what the error also talks to us about, that hey, you need two required positional arguments x and y, because x and y are having, neither they are having values, do they have any default values. All right. So let me call this as random function new old. Okay. So that when you run it, you remember why this happened. And this becomes random function new, the same copy of this. Okay. Random function new, and it has equals to 0 and equals to 0. All right. We are good enough in the functions, I think. Okay. Right. So let's see some applications of a function. Okay, let's see some applications of a function. I have some with me, so let me use them and explain you how we can use functions. Okay. So which example should I use? A good old RC calculator. The same thing that we did in so many lines of code. Now, once we define a function, right? Once we define a function, what I can do is I can use the Darcy calculator in one line of code. Okay. 1 2 3 4 5. Okay, whatever. Just don't just forget about the logicality of things. As a reservoir engineer, just ignore them right now. But as a Python programmer, this is just one line of code, and it is very understandable because we can see Darcy calculator name is much more understandable for some newbie as compared to showing them the whole code. Okay, so using functions also makes things much more readable or presentable. So your code becomes better on readability aspect as well. Okay, so that's about the Darcy calculator. What do we have? Let's look at uh, exponential decline function. Exponential decline function. So you can create an exponential decline function like this, where you are asking for initial flow rate, the b, decline rate, and the time. And you need to, there is one mathematical library in Python. You can import that, import math. If you do not want to use 2.71 and rather you want to use the actual value of 2.71 or e, you can use math.exp and provide in that you can provide minus b to and t. Okay, and you run it and you can see q exponential 1000, 0.05, and at t equals to 0, the answer should be 1000 only, right? So you can see q exponential. Okay, let's look at a few more examples if I have. Okay, let me look at one good example. Fractional flow. Everyone knows about fractional flow. What is fractional flow? When we are trying to produce from a reservoir, we tend to inject water at times so that the water floods oil to the oil well, a typical fundamental of water flooding. For water flooding to work out well, we want our water viscosity and oil viscosity to be shoulder on shoulder, so that the mobility of both of them is at par with each other. Ideally you want a piston kind of flood. You don't want water to just finger through oil globules. If your water is very thin and your oil is very thick, your water will just rush through the oil and it will not be flooding or pushing the oil. And this calculation of fractional flow, it tells you how much in the current scenario, based on your water viscosity and oil viscosity, how much is your water cut on the particular position or your production well. So these are the three calculations, like I told you, step 1, step 2, step 3 kind of things. Now this is an algorithm, and you do not want to keep on writing this entire thing every time a water flooding scenario is encountered in your code. What you can do rather is you can create a function like this. I'm saving some time because this is just a demonstration. in your own projects, you will see some other functions that you will create. You will rarely create example functions again. So I want you guys to remember the fundamental concepts of creating a function. So you can see all the things that you see up here, they are happening in this function, fractional flow calculator. The aim is to return the FW. Okay, so basically the input is SW, 1 minus SW, which is SO, assuming that our reservoir has oil and water only. So if 20% water saturation is there, 80% oil saturation will be there, and vice versa. Viscosity of water is important, oil viscosity is important, and all of them combined, they together help us calculate fractional flow of water. And you can see that's exactly what's happening. And we are returning this entire thing. So you can use the fractional flow calculator and provide all of them. Now, again, we have default values. So even if you did not provide all of them, at default, you can have them. One hint for everyone, one good practice is whatever function you have, you can press Shift plus Tab to see the default values. If you press Shift plus Tab, you can see the default values. OK, now what if you ask me that, hey, can I provide some documentation? Yes, you can. You can use this symbol. OK, 3 string marks. Whatever you provide within this, for example, if I provide this, if I provide this as a documentation, this will not be executed in Python. OK, it will not be executed in Python. Just that if I press Shift plus Tab from within the function, you can see the entire doc string. This is called a doc string, which is the documentation of a function. You can see the theory is displayed here. OK, so I can write my message. Hey, this is fractional flow documentation. So you can see if I press Shift plus Tab here, hey, this is fractional flow documentation. OK, so these were a few examples about functions. Everyone clear about how to use a function, how to create a function? At least we can return things and do some calculations. Are you feeling a bit confident about some of your own calculations that you can set up using a function? If you are at least feeling 5 out of 10, 5 on 10 kind of confidence, that's good enough. Trust me, it is. Because the syntax, no one expects you to remember. Just that you must have a reference document with you, which will be this notebook, and some logics that you must have understood in the past. And you do understand how to create a function. OK, and yep, let's look at the third topic for today. Or maybe let's solve some example. OK, let's solve some example. So basically this that you see on your screen, question 1, asking the user for porosity input and printing the according statement. I want you guys to create a function of it. The idea is to create a function whose input is porosity, and the print statement, I mean, this part goes in as the function input. If you want to return this string as output, you can return it. If you want to print it, you can print it. Both are two different things. A return can be stored in a variable. A print is just a demonstration. It's just a pop-up print. It can never be stored somewhere. OK, so I want you guys to, just transform this logic to a function. I want to see how you name a function, how you're transforming logic to code. How can you do that? One of the very important considerations, logic to code. OK, let's take 2 minutes. If you want me to paste it in the chat, I will paste it. I want you guys to transform this to a function format. The idea is you pass on porosity value as an input, and the resultant logic is returned as an output based on the truth value. Is anyone able to do that? Let me do that on your behalf. All right, Kapil has an answer for us. The naming is good. Porosity check tells the user what is happening in the function. Porosity is taken in as an input. Then we are, let's see what, let me copy Kapil's answer in my code. Converting question 1 porosity check to a function. So there you go. This is the logic that we had. We had a porosity. Now, because we are taking this as a user input already when we are using a function, we do not need this input statement because we are already providing it as a part of the function. If you use this as well and then inside the function again you are initializing the porosity value, then there was no need. This is again anyway going to overwrite what you expected or imported, right? So we can remove this. So this porosity comes in checked for F poros. Yep. Krunal, I think this is also good. Return, you need to return. I mean, yeah, you are not returning anything, which is good, which is okay, but you don't need to unnecessarily type the return keyword if you are not returning anyone, right? So in this case, this is one variant of creating this function. Okay, now let's try it. Porosity check. If I provide 10, you can see maybe it is a carbonate. Now, what if I wanted to return this? Because if I store this as result like this, okay, and I check the result, nothing is printed. Result is having no value. Okay, type of result, none type, because we are printing things. Printing is as if the fruit on the tree is just smelling good. It has not come to the ground to be captured in your polybag. Okay, so in order to return something, what we can do is return statement. We can create a return statement as a, rather than printing it, let me create another function, and this should finally seal the deal about functions. Okay, rather than printing it, I will return things. Return this statement. Okay, this is a sandstone. Otherwise, return this. This is a tight sandstone. Okay, you can use whatever logic you want. Okay, output, you can create an output variable and store this string inside the output and return this output. Both of them are the same thing. Okay, you can repeat this. Output equals to, this is a tight sandstone. Return output. Okay, and again repeat this for other cases as well. Maybe it's a carbonate. This should be very clear now what a function is doing. Return output. Else we don't want to return an error, so let the error be an error. Okay, so porosity check. Now if I run it, let's check with the error first. -10. Okay, it will not return any value. So if we store this as v, you will see that v is none. Okay, but if we provide 10, you can see v has a statement inside it. So is this very clear? If it is clear, type yes in the chat so that we can move on to the final topic for this session, which is the very important iterative power of computers, for loops. I want 3 to 4 yeses or thumbs up so that we move forward. That's like my motivation. All right. Final topic for today is